So hello everybody. Please let me know if you can hear me well and see the screen. So please let me know in the chat. So can you hear me well? Plus, minus? Hmm. Yes, okay, so great. Great. So let's then dig into the tasks. Okay, last time we ended up by building the kind of structure of object-oriented programming of the way how we will have the game objects there. We will finish that part and I will give you a new template today. And the homework was to make sure that you can drive around the little spaceship. And let's check how we succeeded. And I will help also you to fix if you have some problems. So So here we have the code of one of the students. So it actually helped me understand a little bit more how well do you understand what I'm showing you. And if you have any questions while I'm showing this or explaining other things, please let me know. So first of all, let's try to run it. So if I try to run it, yeah, there is an error here. And the other thing is, remember that you need to remove not remove, but set up the emulate terminal in the output console. So you can do that by clicking on the run, edit configurations. So here with little triangle, emulate terminal and output console. So that would be taken care of clearing the screen. But then let's look at the other problems. So if you look at this code, so first of all, so this student did the first part correctly and then created the instance of an object. So this part is quite critical to understand regarding the instance of the object. So the object itself, the class position 2D, right? So that is the object itself. So this is like your computer program, and this is like copy of that program, and you can make a lot of small copies of the program. It will have the same contents. So this part is okay. So this is the position of the rocket or the spaceship in the middle of the screen. So that's good. Then here below, I suspect that this person wanted to make sure that the spaceship positions are then reflected into the scene where you want to draw the spaceship. But the problem with these lines from 97 till 100 is that this is not the this is basically creating an object to non-existing instance. So in other words, what is happening here is lost in black hole. So it's basically you write something like this, where you ignore this first part. You basically do not write it like that, but in general it doesn't. It's not at all different from this kind of syntax. You're creating some kind of instance that you immediately forget about. You just like delete it out and say, I don't care about that instance anymore. So you should not leave out that instance. So it cannot just disappear. You almost never write your code like this. So basically up here, you already created your instance of an object. So let me check. So first of all, these lines should be deleted. So you don't need to create a new instance of an object. So you already have the instance of object positioned rocket, and this instance is available everywhere in the scope. So starting from these lines, it go down, 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 Also inside this scope, even in this scope here, you can use it wherever you want, this position rocket. So regarding to position rocket, so first of all, if we print out position rocket x and y, right? So these positions will be here the same as if I would printed them out here or any other place in the code. They will be the same. So we don't need to create a new instance. Hopefully that's clear. So, but the way how then to use these uh, positions x and y here in this part would be just using that instance dot y and position rocket dot x like that. So, and I will remove the comment. So like that. And now we're using the position rocket y and x contents of those variables inside. If you go up here in position rocket here, I mean position 2D class. So you see, if I give something in val here, it will be stored in this variable with 2 underscores x. And then when I get it out using the x property or the function, I will return this variable that I just set up here. And also, if I set variable that is not compatible with this kind of condition, that it should be inside our game, not outside our game, so it will not be recorded. Only the positions that are inside the game will be recorded. So if we drive down here, scroll down here, so first of all, we create a position rocket, then we use it here. So very simple. First here, create position rocket inside this object, in this instance, and then we use this instance. If we would create here another instance, position rocket 2, and would set some kind of different like inputs here, so this will be 0 and let's say 5, whatever. So when I will call this part, it will not be anyhow connected with those values that I enter here. These are totally two separate things. Even though they use the same class, the instance, position rocket and position rocket 2, contains variables inside that are completely different to each other. And if I would write here print position rocket x and position rocket 2x, they will be different. So far, is it clear? Let me know in the chat. So far, is it clear? Plus, minus. If it's not something not clear, please try to type in some question regarding, you see the line numbers here? Okay, so both saying clear, that's good. So so far this part will be fine. Then the next part. So first we finally got out the variable from the position rocket y and x and put it in the scene, so that's nice, but we need to change the variable as well. So we do not change it in this way, as in this line, 133. So we cannot like interswap between different types of variables. So this type, as it's written right now here, is basically saying, create me an instance of list. So with the square brackets, this is a complex type called list, and like array or list. So you can store whatever you want. You can store here like this, and it will still work, no problems. And this is nothing related to the position rocket at all. So to create something, if I would want to create a new position rocket, then I would need to do something like this, and then I would pass the val x and val y. But this is not necessary. We do not need to create a new position rocket here. We can use existing one and just change the internal values. So please do not do this or this or this. So this is all unnecessary, and the last line would cause an error and would not work at all. So you cannot just, so it would work, but it would override the position. It would not be position anymore. It would be list then. So instead, what we can do is just use position rocket dot x and execute this equation here. As you remember, this equation is exactly the same as I will write down as it would be like this, position x minus 1. So this is just a shorter way to write exactly the same thing like this, okay? So this part, then let's move the other part. And also here the y, of course, like that. And the last thing is, this part is totally unnecessary. It's not needed here because we already implemented that part inside our properties. That's why the properties are very nice, because we can add some additional constraints to the values and check them. So we do not need some kind of code like this here. So very simple. So we are modifying the data inside our instance of an object over this for loop. We are not creating new instances anymore. Is it clear so far? And do you have any questions? Is it clear so far? Plus, minus. If there is something not clear, then try to write about which line and what exactly could I explain more. Don't be shy. You can just like ask about which line. Okay, so nice. Okay, everything clear. So let's test if this works then. So if I run it now, so first of all, it's using the Windows clear command. Okay, so in the last template I fixed that, but you can, of course, it's not the big deal. For Linux and Unix and type of systems, you need to use clear, not CLS. So I run it again. Seems like working. Yeah, it works. So I can go to the side. It does do not crash the game. I can go back another direction. Do not crash the game. I can go down. And hopefully it will not crash the game. Right. So it's working very well. So you see, like, you did some part of what was required, but you kind of illustrated some things that were not clear regarding the way how you create an object. So I really hope that now it makes a little bit clearer, and after this session should be even more clear. So then let's examine the next work that we had. By the way, please submit homeworks way ahead of the schedule. It's not okay to submit at the last moment. So here, usually in Python, you do not make these spaces around here. It's just like the Python style. That's one thing, but that's nothing that special. So this part, okay. So why exactly would you define, like copy the values here? It's not necessary at all. So you just would use this part directly here and this part directly here. So I would understand that if there would be a function calls, like for example, call something and then get x, then this would not be okay at all. So you never ever write code something like this. This is totally bad. So the way how then you would do is you first call some result and then would get result x or something like that. Then there's like split out, so they're not chained together. But in this case, there is no chaining. There's like very minimal chaining. So basically the instance and then the property. So that's like that should not be done with a like temporary variable there. So, and if we go down here, this part is fine, but again, why would you need this? So if you already have that selection, maybe you don't understand that you have it up here. That's that. So if you get a value here, you first have the condition here, and only then set the value. So you should not have also this part here. Let's see if it works. So try to run it. Okay, this is kind of, yeah, it works. There's a little bit different emoji symbols. I think if you use the kind of emoji symbols that are the same size, then it would not do these strange artifacts, but in general, it's fine. So, okay, so I think it's general good job. This was done correctly. Only some parts of the code were not really nice, and also never comment code. Like this is also a bad idea to comment code. Like that's why you use source like source control, like git and other things. You should not comment code. So that's another part. Okay, so and with this, let's go back to the tasks for today. So briefly return to the UMLs, and then we'll start implementing them. So here we had this kind. So first of all, now I will do some of the stuff with UML. You don't need to copy what I'm doing right now. It's just will be like a wireframe or like blueprint for what you need to code. So okay, let me check. So what we have is a position 2D. The position 2D composition means that that kind of object is embedded inside this object, and this is called encapsulation. If you remember, there are three things in object-oriented programming. So the encapsulation, this part that we use some kind of object inside another object, and it's not widely available from outside the world. You need to use getters and setters. So that means encapsulation. So the other part is inheritance. So here you have the extension from the element to the wall and extension from the element to the movable element. So we are adding new features to existing class. So we are not like rewriting it, but for example, movable element have direction, speed, but it also have automatically position and character. So they are embedded inside it, like without any additional work. So that's one. Then we have draw function here. That's fine. But we need some other functions here as well. Let me see, can I add it not like that? There was a way how to do this. Okay, like that. So I will add some other functions here. As again, you don't need to write this. It's just like the blueprint, and we will code it just in a second. So then the last thing. So let me write it actually down here. So for the object-oriented programming, we have the encapsulation that we already understand, hopefully. So the idea that we can embed some kind of variables inside the class and make them not available easily from outside the world. And that makes all of the code much safer and basically more manageable and understandable. So first of all, this is encapsulation. Maybe I should make it this a little bit larger. Okay, this will be fine. Okay, encapsulation. Then the second one is inheritance. That is something we are starting to explore. Inheritance. So this is extension of the classes. That is inheritance. So you have super class and you have child class. So let me see. So super and child class, and the other like encapsulation, it's just like embedding other variables. So embedding variables. So these are called member variables, by the way. So that's, and the last part is polymorphism. So third, polymorphism. And this means is that basically do not care about object type, and basically do not need to implement all of the functions even. So like kind of interfaces, that's one way of looking at it. So here we have draw function, and now we will have the first polymorphic feature. So that will be the update function, update, and this will contain the delta time. And this will be pure virtual, so this will be just virtual. So in C++ languages, C++ and that kind of languages, there is a very nice way how to make a pure virtual functions. In Python, it's not really totally virtual, but similar. So the virtual functions, what it means is that the element itself will never have the function implemented in that object, but it will have the definition, only the definition. So the idea is that if I would call the update function directly to the instance of an element, there would be an error. So let me show you what I mean by that. So if I create an element of element, and then would call directly the update function, element update delta times, or maybe let's say whatever 0.1. So if that's a virtual function in C++, that there would be a crash here because it's not implemented at all in the object, even though the definition exists there. But if I would create the same element from movable element, which do implement the this kind of function. So let me add here the other function. By the way, I will clean up this part as well. So here will be the check collision with some other element. So if I have here not pure virtual function, but actually implemented function, then there will be no error anymore. And then there is also a thing called casting. So basically, it's also part of polymorphism, the idea that the element here is it could be the derived of the element itself and treated as element itself, but it's actually the pointer is showing to object that is movable element. So I know that's a little bit too confusing. No worries. Just bear with me. So look at the functions, you will see how it works. So here we have update. So the polymorphism, I guess, is the most difficult to understand in the very beginning, but I will show you some of the examples and you will get it. So update check collision, update check collision, we have this here, other, like that. So we have movable element as well. What else we need? Well, so we need the player probably and the rocket. Okay, let me ask you a question. Player, so we will delete stuff here. So of which object should we extend to create a player? So which object should we extend to create a player class? So what do you think? So you see what options you have. You have wall, you have element, you have position 2D, you have movable element. So which object should we use to extend player? Meanwhile, I will maybe add some stuff here. Okay, so Christiana is correct. So we should extend movable element, not position 2D. But it's very good that you are actually interacting and giving feedback, because there is a wrong answer, but at the same time it's better to have wrong answer. I really appreciate that. So it's if you just copy each other's answers, that's really lame. So that's good. I will explain in a second. I'm just trying to find where it is. So yeah, the player is movable, right? So that's kind of simple idea, so that the player can move around, and that's why it should be movable element. It should have speed and direction. The position 2D itself is just one part of everything that we need, because if you look closely, the position 2D actually is also used here. Maybe the diagram is not that great. I should add the other composition here. because the position 2D is also used here for the direction, by the way. So the idea that it can be used either for like making sure where the object is located, but it also, the same structure, exactly the same structure, can be used for determining the direction on which the object is flying. So that's why it is not like that, like you wrote before, but hopefully it is clearer now. Let me add here 11 size. Okay, extend, make this style a little bit nicer. Okay, so yeah, so this will be the player. Okay, the next question then, if we have, so okay, the player actually should look a little bit different. Where is my player character? I would like player character to be something like this. Okay, like that. Okay, so then the other one, just a second. Um, the other thing will be the rocket. So from which class should be extended for rocket? So which class should we extend? Should we extend for rocket? Well, so I will meanwhile fix the rocket part. So there will be a character of rocket, whatever. So which should we use for the rocket? So what will be the superclass of rocket? So the superclass of player is movable element. What will be the superclass for the rocket? Okay, we have one answer. What about rocket? Okay, so element is not too bad answer. So the element could be the extension for the rocket, but the correct answer would be movable element, because the rocket also have direction and speed. So it's not something that is sitting in just in one place. As you see, the wall extended from the element directly because it do not have any capabilities of moving around. But in this case, for the rocket, we do have these capabilities. So that's why it would be nice to have the extension of the features from the movable element to the rocket. The one thing that's missing also here, I hope that I can make it work here, so is that the player have also ability to move directly from the keyboard. So we could have the up function. By the way, the rocket would be moving with some kind of other logic. So there are differences between rocket and the player. So first of all, the player can be moved by the keyboard, and the rocket will be moved by some kind of initial position and the speed where you shoot it out from the player's position. So there is a difference of the functionality, and also the player would be constrained and only moving in the x-axis, whereas the rocket will be constrained on only moving in the y-axis. So you can easily imagine that there are some significant differences. So left, duplicate, right? So we have these kind of functions here. Okay, so let's don't go too much detail more in these parts. I will just copy this part and add it to the Jamboard. and then we will, I will give you a template, and we will start coding up this thing and make that today we can play around with using this kind of structure, and also detect even collisions. So I really hope that we will get today till the detecting the collisions, and then you will have very interesting homework. So let's see, so I'm adding this as in the Jamboard. So this will be your blueprint for the classes. It's like very rough, so there are probably some things missing here, but it's fine enough. So okay, I'm moving back to the code, and now I will drop in the link to the template. So the template link, and I will show you just also how it looks like. So for the session 4, I really hope that it works. So let me know if the template link works. I will try to copy it again. Okay. It's kind of marking my my username in the link, but it's, I hope it's working. Is the link working? I will also add the template now directly in the video notes description. So it will be just in a second appearing, template. So it's now also in description. So yeah, let's actually write the question will be, is template ready for work? Now you have multiple places of getting the template. So okay, plus minus if there are some problems. I will show you the template, explain it. So I have one plus, let's see. So okay, so first of all, to run it, again, remember that you need to configure so again, it's you need to configure the edit configurations, emulate in terminal. So if I run it again, let's see. Yeah, so now it's working. So it's just a like black field. Okay, so but the code itself, it's interesting. So first of all, here in the position 2D class, I added additional parameter for the constructor that is checking, do we need to check the constraint of X and Y in the scene positions? So the idea is that if we want to use this position 2D for the direction, then we do not want actually this to be enforced. So for direction, maybe it would be other kind of condition where you would check if the direction is in the range from -1 to 1, but you don't want to force it to be 0 at minimum. So that's why I'm adding the new parameter here. And also you notice here is a new syntax here. So in Python, you can give the default parameter. We're using this kind of syntax. So if I would create a position 2D with only val and val y, then, and not showing this parameter, it will be always true. And here is a very important thing to know, that you can do only this with simple types. If you will start giving here a complex data type, you will have very bad things happening. It's regarding the pointers, but I will not explain now in detail. But you should never ever give as a default parameter for any Python function any complex type. So that's one thing that you should make sure. So then the element have the position here. The interesting thing is that, for example, the character, even position, maybe you don't even need to have it as a setter, because that is an instance to an object, and we can directly change it just by using the pointer here. Maybe we don't need even this part. So and if you see at draw scene, so here we just like converting the position to integer, because you will see in just in a second that the positions we will have as a decimal numbers actually, but the scene is a discrete matrix, and we are scaling. So if we, for example, would have this position as 0.7, so after this is not good example. So let's say 4.3, it will just, after this integer operation, will be 4. Or if it will be 5.7, it will be floored down as well as 5. So, and if it will be like 0.6, it will 0.6, it will be converted to 0. So this part of the code is changing the decimal number to floor, like lower number of integer. And then we have these two functions that we previously defined as virtual functions or pure virtual functions. So in this case, they are kind of like virtual functions or interfaces. So here the idea is that the pass keyword means that we do not do anything there. If we would not have pass keyword, this would be an error. So if I delete the pass keyword, you see the red line here, and it says that the function is not completed. So if I want a function that do nothing, I need to have pass keyword here. So, and this is very useful to have functions that do nothing. You will see that in a second. So then we will have the val element, and the val element have as a default parameter position, and we set the position here like that. We can do that for other elements as well, by the way. I'm just showing that as an example here. And here I can also show you the bad thing to do. So you should never ever do something like this. Like if you do this, you will have very big problems later. So do not do that. So only simple types like booleans, like integers and things like that can be passed to, like a default parameters. Even lists and dictionaries cannot be passed as default parameters. So then the movable element, we have here the character, speed, direction. Direction now for the position, see here that we have is check scenes false. So this is very nice syntax in Python where you have the kind of, for example, I don't know what is the first and second parameter name, but if I can add easily these keywords here, so val x is this, val y is this, now the code becomes much more readable. Beforehand, I had to know exactly what is each parameter. So then we have update, left, right, up, down, check collision. And now this part we have the at line 118 or so, we have the first position created, middle position of our game. And we have to do for the elements. The elements will be our main list of elements that we want to draw in our game. So we can start adding some stuff here. Let's do that. So first of all, let's add the player. So player will be the instance of a player. And for the instance of a player, we don't have anything to do to pass in the constructor. So that's why we can then have it dot position and pos middle. So now we are kind of losing actually the player dot position. Everything, the pointer of position is lost now, but we are replacing it with this new pointer. So if this would be some kind of C++ language, that might be a problem. For the Python, this is not a big problem, but still you need to understand what you're doing. So here then we have elements, so we're adding in our list the player. So by the way, again, this is creating a list with one element of player, but we can do exactly the same code in another way. So this is one way of writing the same code. So let me show you how to do this another way. The other way would be elements append player, like that. So both codes are equally same. Hopefully you understand. So are you okay with this part? Is it clear also? So is this part done? And okay, plus, minus. We'll go to the next part. Excellent. So that's good. So by the way, to have a plus, you should run it as well. So always try to run it. Do you have an error? No errors. That's great. By the way, I implemented a new feature. If you press escape button, it kills the program. So you don't need to press the red button, you just press the escape and it kills the program. So that's fine. So we added the player, so that's brilliant. So now we have code here written draw elements. So how we could draw the elements then? So that's quite easy. So for element in elements, so this is a loop where we go through each element in the list of elements. Now in this moment we have only one element in the list, but we want to write a code that would work with any kind of elements. So then we have element and dot, and now you see that it automatically actually, let me show you, gives you the ability to select the functions from elements. And here the one is draw, and we pass this scene here like that. And the interesting thing is, something that you should start to understand is that this part of code works because we are passing pointer of this list complex data type inside some function that will change the actual memory of that pointer inside that function. So we don't need to write anything like this. We don't need to write anything like this, like where we assign the value from what's coming out of the function, because the pointers take care of this. So the idea is that we pass complex data type or pointer, or in other words, pointer basically, inside the draw function, and it is changed inside that function, and we do not need to retrieve it afterwards. Hopefully that is something that is clear. Okay, so is it clear? And without my comments, is this part okay? So is it clear and okay? So plus minus. So we are changing the scene inside that function of an element, and basically, well, we don't need to kind of like do something, return the result, and then store it back in the scene, because the scene is complex data type. This is something that we cannot easily copy. So just to remind you that if I would do something like this, then A and scene would be exactly the same object. If I would change anything inside A, it would automatically be changed also in scene, because this is a complex data type. This can be done only with simple data types. With complex data types, anything that I change after like assigning the pointer to some other variable will be automatically reflected also in the source variable, because they are pointing to the same memory location. So I hope that this part is clear. So let me know in the chat, and if not something clear, then let me know as well, and try to run it so that you don't have bugs here with these two lines. So if I try to run it myself, so now the spaceship is drawn. So okay, so that's fine. Okay, the spaceship is drawn. So let's go down. So then the next part is we should implement the flying around. So the left, up, right, and so on. So here you have a global variable that is actually not too good, but in this case we have it. So player dot. So let me actually share how it looks like. So player dot left. So we will call that function. Then for the right, we will call this function. Then for the up, we will call this function. Then for the down, we will call this function, and that's about it. So these four functions. So I will also now add these parts to the Jamboard. So so if you like somehow do not manage to write down all of the code, you would catch up later. So let me check. So yeah, I'm adding this part to the Jamboard, and then I will scroll quickly back. No worries. So probably looking at the code, you should be able to complete the code yourself as well. So this part was something we added. So I'll drop this in to Jamboard as well. And we also added this part of drawing and passing the pointer of scene of complex data type inside the function where it's modified. So this is kind of in place function because it's kind of modifying the variable without returning it at all because it's not necessary. So we're adding that part. And now we're in the bottom part here. So let me check. So is this part done? Plus minus. I realized that if you have two displays, two monitors, then these sessions are much easier. If you have just one small display and you're making this like picture in picture, it's maybe not so easy to follow. So I appreciate that you're following. So the player left, player right, player up, player down, quite simple stuff here. Okay, so great. So now there's in the bottom part to do update elements. So what I mean by update, so maybe we should write that part as well. So let's scroll to the update function. So if you see that for the movable object, I mean not for the movable, but for just for the object itself, the element, we have update as like pure virtual or just a virtual function. Then inside the movable element, we actually have the update function we should add to do here. So let's implement the update function here. So what is update doing? It's actually making sure that like depending on your computer speed, it will always move the spaceship at the same speed. So we don't want that computer game would work different depending on your like kind of computer's CPU power. You know, like if you have like I don't know, like very powerful computer and then your spaceship is flying twice as fast as others. So that's something we don't want. And there is a typical way how to resolve that. So here's then the position X, and the position X is plus, remember this syntax that we already discussed many times, that is position X is position X plus something, plus equals, right? So then that part, then self, then we will select direction. From direction, we will use the X. Then we will multiply that by self speed. So each element can have different kind of speed, like the spaceship, rocket, the alien also can have different kind of speeds, right? And then the last part, very crucial, is delta time. So we are depending on the intervals between the updates and the renderings. And this delta time is kind of like scalar. If you have very fast computer, the delta time will be very small. If you have very slow computer, the delta time will be very large. And regardless of your computer speed, the game will go the same speed, whatever. So we will have this part for the X, and we will have the same for the Y here, right? Like that. And also, please implement these parts of moving the player in correct direction. So for example, direction left. So direction left, of course, direction left is X minus 1. And the direction, so direction Y should be then 0. So I don't want actually to create a new instance of direction. We just use the same instance and set the variables there. So like that. And yeah, so you should do the same for the right up and down. I guess you should be able to understand so that the right is in the opposite direction, right? And the up is basically by the y-axis, -1, right? And here +1, right? Like that. So please let me know if this is clear and done. Is this clear and done? Okay, I see a question. So the difference between two underscores and one underscore is means that they are protected and private variables. So private, so the one that you have in first one is protected, and the other one is private. So you like to make these codes work properly, at least for most of the ideas like PyCharm and others, you should use one underscore. If you use two underscores, then if you inherit using the superclass some kind of feature, it might give you a kind of error or warning. So please do not use two underscores. So in general, like in some cases, it's very good to use two underscores, but in this case, let's keep with one. So it's called protected variable with one. So is this part clear and done? So plus, minus, and if something is not clear again, then please let me know. Meanwhile, I will drop this part into Jamboard, into slide number 4. So let's wait for Christina. Okay, great. So this part is, so let's, okay, first of all, before moving onwards, let's run it, see if there is no bug. Okay, for me, there is no bug. So that's good. Then let's move down here. So now it's asking to update elements. So to update elements, we can do the same as for the drawing elements. Just copy these lines basically, move it here, copy with the same indentation, with same tabs. If you have different tabs, there will be an error. So element, and here the update. Only difference is that we will pass dt, delta time here, like that. And basically, I will drop also this to the Jamboard, these two lines. Now you should be able to fly around your spaceship, or the rocket, whatever, like I guess spaceship player around the scene. So if I run it, see, using these two lines. Now if I press the right button, the spaceship automatically flies by itself in this direction. If I press down, it flies automatically in that direction. You can change the speed, it will fly faster, slower, and so on. So I don't need to keep pressing button, and just once press, it goes in that direction. And if I press escape, it ends the game. So is that part done? Is that part done? Plus, minus. So if you have some like bugs and errors, maybe you can resolve them a little bit later. But I hope that there is nothing super crazy with the bugs. So I see 1 plus. Okay, 2 plus is right. So now we have collisions and walls. So the things that I still want to add. So first of all, we already have all of the code necessary to start adding interesting things like walls. If you go now to the elements positions here. So let me show you that. So we could actually add walls also directly in this element part here. Okay, let's not complicate. Let's add it using here like that. So there will be 4 walls. So wall. So first this will be first wall. So the wall will be position is equals position 2D 2, so it will be from the left 2 items, 2 like positions from the left, and scene height minus 4 positions from the bottom part. This will be the first wall here. Okay, let me see. So the wall, I need another bracket here. So just to make it clearer, I will add these spaces, but you should not add them. So we have one wall, I copy the same line 4 times, and then I add the 4, 6, 8. So we have 4 walls. So I will drop this also into the Jamboard. Slide number 5. Okay, so we are adding new elements here, and it should not change the way how the game works. So if I'm running it, now you see there are nice 4 walls, and I can fly through them, but I don't want to fly through them. I want to have a collision with them, right? So we will need to have a collision here as well. So if I press escape, I can exit. So let's see. Are walls ready? Plus, minus. Great, great, great. So then the collision part now. So we check collisions. So we will need to check collisions. So with itself, so let's write check collision with itself and other element. So, and the other element is coming inside this other variable. So, and then the is collision variable is set false by default, and it should be true if the collision is existing. So to check to get the collision going, we should then check, I mean the detecting, so we should then use the self position, of course, and we cannot do something like this. So again, there is a good way to illustrate what is the complex data type. For complex data types, it would be very nice if I could do something like this. There are some very specific ways how to do that, but this is very far away from what we're doing now. So basically, you cannot do something like this. So let me check in the chat. So do you understand why we cannot do this plus minus? So these two are complex data types, these positions. And now it would be very nice if we could write it just like that. If the positions are matching, then it means that we have a collision. But we cannot write in this way the code. So do you understand exactly why we cannot write it in this way? Plus minus? And if minus, maybe, yeah, minus will be enough, so then I can explain a little bit more. So please engage. Hey, what is it? Okay, minus. Okay, great. So you don't get this part. So here then this is so basically what you're writing here, if you're just having this kind of equation, if this is equal with that, basically what it means is, in other words, so is this memory location equal with other memory locations? So memory location is self position memory location equal with the other memory location? It is not. So it is not writing if the contents are the same. It is not checking if contents of position X and position Y are equal. So this line is checking just if the memory locations of complex data types are in the same location, which is not the case at all. So, but if we would like to check if the actually positions are overlapping, then we need to examine the contents, and to do that, we would then need to do something like this. So let me keep this part commented. So this is not the way how to do this. Never ever do something like that. So the way how to do this is then as checking if the x's are matching and checking if the y's are matching, like that. And now, if they are matching, that means that their contents, because x and y is not a complex data type, these are just a floating like numbers, you know. But the position itself is not a number. Position is a complex data type, and complex data type instances are just a memory locations. They are not actually data. So is it clear now? Is it clear now? Plus, minus. If not really clear, maybe you can write exactly what part is not clear, and then we'll move on to the last sections. So this is wrong. This is very wrong. So you should try to understand which is complex type, which is simple type. So that's basically very important distinguishing in the programming. So okay, I'm dropping this part of the code in the 5th slide, and now the last part is that we need to check collisions in between all of the elements in our game. So and if we have a collision, then we want to have a crash of the kind of like and end the game. So to do that, we should use some syntax that is creating permutations. So permutation loops. So to do that is the first loop will be going in range of len of elements. So maybe even we should write down as a separate variable to not confuse you. So this means elements. So this means how many elements do we have inside our elements list, right? So we're going through the elements list here. And the range means that we will have I values. I values will be 0, 1, 2, up till len elements minus 1. So that is what it means. So this for loop. Again, please do not write the comments. So then the other part is for y in range. By the way, maybe I should write in more detail. So here will be from 0 till that part. And here we will have from I plus 1 till len elements. Like that. So we will have something like that. So here in this case, the other loop is going from y. So if the first one was 0, the other will be 1. If the second was 1, the other will be 2, and so on. So we are trying to examine all of the combinations without repeating them. So we'll go through these combinations, and then we will have the elements selecting some element and checking the collision with elements of the other item. So yeah, so we're checking each element with each other element without repeating the checks. So we don't need any if statements, whatever. We don't need waste resources, and this should be like quite straightforward permutations generating loop. So by the way, if we have collisions, so is collision Then we want end the game. So if collision, then print end game, and is game running should be false. So like that. I hope this is working. Let me double check. Okay, no errors, so this is working. Okay, so I will drop this also in the Jamboard. You will need to catch with this part of the code later, so because we're running out of the time, so I'm adding this part in the slide 5. But now please please pay attention to what I will be showing you now. So you will finish these lines of code later, and you can add print statements. Remember that you can add these red dots, and then you can debug your code using this small bug up here. So you will explore the code yourself and complete it, but now please keep attention to what I will be showing you. So now, if we run this code, you will see a very interesting defect. So now I see my spaceship, I press down, I fly into wall, right? And nothing happens, it flies through the wall. See, and at the end it stops. So why does it happen? So this is mathematical bug basically. So if we go up here and look at the line 108, so why the spaceship is flying through the wall? Why the spaceship is flying through the wall? So do you have any ideas? So plus minus, you have, if you know why it's flying through the wall, then type in. If you don't know why it's flying through the wall, then type in minus. So the problem is in line 108 here. So in this line, the problem is. So please give me some guesses. Again, this is not kind of coding task. This is more of like a logic task and understanding of just the mathematical equations, very basic equations. So is collision changes when it crosses the wall? So the it so I don't understand that question in general. Like the collision should be set to true when the positions are equal, and you see that we went through the wall and there was no detection of the equal. So okay, I see some answers on kind of very strange, but still thank you for trying to interact. So the problem here is following, that the position and position other is decimal numbers. So remember that we are getting these positions using this equation where there is a delta and speed and direction, and all of this is decimal numbers. So what it means that the positions could be something like like that, you know, and to get the exactly equal, it's almost impossible. So that's why we should scale, like round them up. So the one way how to do that would be to use some kind of rounding. So round, I think it would be better than just flooring using integer, because if the rocket flies from other direction, we would want to detect the collision sooner than later. So this would be round, oops, round, and here again round. So the round, like it's a little bit different than integer. We could use also int here. It would just behave a little bit strange, but it would work. So the round, instead of integer, would do something like, if I have 0.7, it would round to 1. If I have 5.6, it would round to 6. And if I have 5.2, it would round to 5, like in mathematical rounding, right? But the integer would do different things. The integer, so if I would do the integer of 5.6, then that would be just 5. So you see the difference, right? So we're adding the round here. So with these brackets around them, because the brackets mean that we are calling that function. By the way, if you want to split this long macaroni in 2 lines, I add like this small symbol here, and then I can split it in multiple lines. So now I will drop this part also to the Jamboard, and we'll test if this code is working. So this will be in the slide number 6. So let's see if this code is working as expected, and can we get a collision going. So I'm flying down, flying into the wall, and we have a collision. Success. See, we have a collision. So that's great. The game is working so far. So I put all of the code also to the Jamboard. Now for the homework, what I want you to do is to implement Rocket. So I want you to implement the ability here with the space to shoot a rocket, and I also want you to implement that the spaceship cannot fly around all of the space, but only through the bottom part of the game. Like, let me show you how it should behave. So the spaceship should, oh, that's not so easy to, okay, now it's okay. So now it's good. So it's oh no, there is a problem as well. It's rounding, so it will be not so easy. There will need to be kind of so there is a possibility that that the ship cannot fly through those small parts, but it's actually maybe not necessary for this game. You will see, because the decimal numbers might overlap a little bit, but I will show you what I want. So the spaceship should fly only in the bottom part of the game, and you could use some different symbols. So you cannot fly upwards, you can fly only in these 2 directions, on left and right, but with the space bar you can shoot rockets, and if you shoot rocket and the rocket collides with the wall, I want that wall to be disappearing. Okay, so from the code that you have right now, to implement this kind of functionality should be super easy. So of course you will need to struggle a little bit if you're not familiar with all of this, but it should not be that difficult. So you should not allow use player to fly up and down. There are very simple ways how to prevent that. For example, you control the buttons, right? You can just disable some buttons, right? And then you have the space bar where you shoot the rockets, right? And when you shoot the rocket, it should look something like this. I shoot the space bar, the rocket goes up, collides with the object, and then, which it did not do, I don't know why, but still, so it collides with the object, and then the object disappears. So that's about it. So yeah,